Well, good morning, guys. Welcome in. It is 9:35, and it's time for us to get going with our Wednesday morning edition here of CPT 168. Glad you guys survived spring break, at least most of us. It's like 1, 2, 3 of our classmates are not here yet. So welcome back. We are in the home stretch now. We have 3 chapters, 3 units left to complete, and we'll be done with our course. And so we need to get started doing that. I will tell you that I worked hard during the break to get caught up on all the missing grading. And so if you haven't looked at your grades, you need to do that in Blackboard. So everything except what you turned in this past weekend has been graded. And we should be able to keep things kind of smooth and caught up for the rest of the way. So we have 3 chapters left. Today we'll talk about dictionaries and why we need to be concerned about that. Dictionaries are not too bad, just a kind of an extension on the idea of lists and tuples. We'll add dictionaries to the group. Next week we'll talk about recursion and algorithms. It's kind of a math class. Notice that on April 12th, 13th and 14th here, test number 4 is going to be open. That's next Monday, Tuesday, and Wednesday. I wrote that test on Sunday and Monday and posted it in Blackboard. And so it's ready to go. And I went ahead and opened up the review sheet for you so you can get that in Blackboard if you want to start studying for it. It's a pretty good test. I will tell you a couple of things about the test since you came to class today. And I will tell you some things as we kind of go through our coverage of Unit 12 today. But the main thing is that it is 50 multiple choice and true false questions. There are no fill in the blank questions. I think I've given you enough of those for the semester. So we just stayed with multiple choice and true false. So all of the answers are in the test. You just have to find them. So hopefully you'll be able to do that. It will be interesting to see if the grades go up much when we take out the fill in the blank type questions. So that's Monday, Tuesday, and Wednesday. Please put it down in your calendar to take test number 4. And then shortly thereafter, we will get to our final exam. In 3 weeks the 20, that'll be about 3 weeks, right? So we will have our last unit, which is going to be on classes, creating and using custom classes that you can create. And then we'll have our final exam the week after that, the end of the month. So that is how it's going to work. Some students have asked me about a final project, and I do not have a final project scheduled for you guys this semester. I'm thinking about adding one in future versions of this course. I would, in a lot of ways, rather have a final project than a final exam. I know some programming classes have both, but because this is a relatively new course, this is only the 2nd semester we've offered it. We're still figuring out the best way to do it. And so I think a project is in the future, but not this semester. So we'll see how that goes. Are there any questions about our schedule? Okay, the most important thing looking down the road here is to be sure and take test number 4 coming up next Monday, Tuesday, and Wednesday. And I will remind you in Blackboard and email and all that kind of good stuff. So let's go ahead and get started on our lesson for today. And I think you're going to find this one kind of interesting. I hope you will. Let's see, why is that not going full screen? There we go. So dictionaries. Dictionary is kind of an interesting word. As I said, it is really a different form of a list. And I think that if you just kind of understand, it's like a list with a few more features. then it's not nearly as intimidating. This unit is not hard. And if you've been studying along and learning what we've been trying to go over in class, you'll have no problem with this unit. So as we get into dictionary, we will see that there are some methods and constructors that have been provided for us in Python to make the management of dictionaries more productive for us. So we'll learn three methods that create something called a view object: the keys, items, and values methods. Now, I don't have it bolded here, but view objects are kind of interesting. We haven't talked about view objects, but when you run these three methods, you create a separate object, which is basically the result of your query kind of thing. And you create an object that is linked to the dictionary. And that linkage between the view object and the dictionary makes that very helpful in your programming as you update and change items in your dictionary. And because lists and dictionaries and tuples and dictionaries are related, there are two constructors that come with all of this in Python. The list constructor, which is not on the list here, not on the slide here, but the list constructor, and also the DICT, which is the first four letters of dictionary, the dict constructor method is available. So the list method constructor will change a view object to a list, which is very important. We'll talk about that. And then the dict method constructor is going to change a dictionary back to a list. So no, I had that backwards. It's going to change the list or tuple to the dictionary. Sorry, getting distracted here with too many things on my screen. OCD is a little tough. Attention deficit disorder. So anyway, probably the hardest part of this chapter is going to be at the very end, where we get to combining dictionaries with other dictionaries, or dictionary of dictionaries, which is like a list of lists. And but we can also have a dictionary has a bunch of lists inside it, or a bunch of tuples inside of it, or a list that has a bunch of dictionaries inside it. So the book calls those complex data structures. They are a little bit testy, and we'll try to help you through that as best we can. So back in Unit 6, so many weeks ago, we learned what a list was. And we learned that a list is really an array, okay? And now in Unit 12, we're going to increase the qualities and features of an array by going to a dictionary. And in other classes, we would call this an associative array. When I teach the PHP class, we talk about arrays and associative arrays. Now, in computer science, which is essentially what we are talking about in this whole course, is computer science, an associative array, a map, a symbol table, or a dictionary, all of these are data types that are composed of a collection of key value pairs. This is off of the internet, not in our book, but I think the simplest thing to realize is we have to have a data structure that has a key and a value, just a pair, well, actually multiple pairs. And so that is what we have in Python. It's called a dictionary. Now, I told you I was going to give you some hints from the test. There is a test question off of this slide, which expects you to remember that this is also called an associative array, a map, or a symbol table in other programming languages. One of our jobs here is to kind of help you understand that Python is not an island all by itself. It is just another language that's doing the same thing that other languages are doing. So if we were in Java class, we wouldn't be using the term dictionary. If we were in C# class, we wouldn't be using the word dictionary. And I've already said in PHP class we would not be. So just realize dictionary is kind of a Python take on an associative array. Another definition from a different website calls associative arrays maps or dictionaries. They're abstract data types. They can hold key value pairs. And and there's actually an example in the book. This one talks about phone numbers. We're going to look at a way to use dictionaries to create a little address book program. So a lot of examples in this unit, a lot of examples which will help us understand this. So just like a list, a dictionary stores a collection of items. The big difference, one of the big differences, is that in a list, those items are ordered. That means in a list, if you put in items A, B, and C, and then you come back to that list later, they will still be A, B, and C. There's no guarantee that that's going to be the case with a dictionary. A dictionary is an unordered list, okay? So you may go back after you create A, B, and C and find out it's CBA. So that is something that we have to deal with, and we will give you some suggestions on how to do that as we journey into this. So realize that a list is known as a sequence, which is not the case with a dictionary. A dictionary can get out of sequence. So how do you create a dictionary? Remember back in Unit 6, we talked about lists and tuples, and lists were enclosed in brackets. Remember that? Square brackets. Tuples were parentheses. So to create a dictionary, we're going to use braces. We're going to be running out of special characters here before long. So maybe this will be the end of this. But anyway, dictionaries are going to be inside braces, okay? And then inside those braces, you're going to have keys and values and a comma. There's a colon between the key and the value. So the key, colon, value, comma, key, colon, value, comma, over and over and over until you run out of data. And so we just call that a key value pair. Now, in lists, when we looked up data inside a list, we used the integer index, just like an array. In a dictionary, as we would do in an associative array, we will do our lookups based on the keys that are in the data set, okay? So that is important to remember, and it's actually easier. To me, it's easier because it's defined for us. I mean, it's words. Humans seem to work better with words and numbers. So I think you'll find referencing keys to be fairly simple. So just realize that typically a key is going to be a string, and it can be an immutable data type, any immutable data type. So down at the bottom here, we have the syntax. So this is the syntax. We'll have a name for our dictionary. We'll enclose it in braces, as you see here, and then a key, colon, value, comma, key, colon, value, comma, over and over and over till you get to the end. Now, one of the neat things about dictionaries, or actually this is true of other data structures, but right now we're talking about dictionaries, we can ignore white space. Python ignores white space. That translates to we can create columns in our code so that we can make this easy to understand. And you'll see all through this chapter in the book, that is the way our writer has this set up. So you see that there's a brace on each side of this two-column data set here. And so these are strings. These are the keys. And you know that they are strings because they're enclosed in quotation marks. There's the colon, okay? And then here's the value. These values are also strings. Now we could do integers, okay, numbers. These numbers are keys if you want to do that. And this becomes very list-like to me. I don't think we're kind of defeating the purpose in this example. And in this example, you can see we have strings as the keys, and we have a string as a value, an integer as a value, and a float as a value. So the bottom line there is the values do not have to be any particular data type, okay? But the keys need to be somewhat consistent, I think, for a lot of reasons, if for no other reason, just to make this easy to understand. And then it's possible also, and we'll see this in some of our example programs, to create an empty dictionary, which we will populate just like we did with a list. We'll use the same strategy that we did when we were working with lists. You print a dictionary just like we did lists, print and the name of the dictionary. And the only output difference is going to be, instead of a simple list, we're going to have key value pairs in the syntax that we just discussed. So that is pretty easy to understand. So my strong suggestion to you as you begin to write your programs is take advantage of the fact that we can ignore the white space and create columns of your keys and columns of your values and put a colon in between them. And that way things will be a whole lot easier to keep up with. Also make sure that you realize that items are in a different order than they were in the statement that created them. Python will actually change the order, as you'll see as we go through this. So just don't be shocked by that. Now we have some methods that we're going to use to manipulate the data in our dictionaries. I said manipulate. Manage the data might be a better word. Get and set are the two ways that we really do it, because we do set and add the same way. So if you want to access a piece of data, you get the data. And if you want to change the value of a key value pair, you set it. And if the key does not exist in the dictionary, when you set it, it will create one for you. So setting also is the same thing as adding, okay? So this is one of the ways that we can access and manage the data, and it's very simple. This is not hard to do. You access the data by referencing the key in the dictionary in square brackets, the same way that we access data in a list when we put the index number in the brackets. And remember all that foolishness about 0 being the first number in lists and all that? We don't have to worry about any of that with dictionaries. All we just have to do is keep up with the keys and the values. I mean, to me, this is a lot easier than a list, but it's a different type of data structure. So if you try to get a key that does not exist, that can be a problem. We're going to see how to fix that. It's a very simple fix. But if you try to get or reference a key that does not exist, you'll get a key error. And remember, our mission in life is never to have errors in our code. So we just want to write a little if statement to check and see if those keys exist, and then we will get them. And that's a real simple fix for that. So as an example, we will keep generating different dictionaries here. So a country's dictionary has a bunch of codes for a bunch of countries, okay? And the syntax to reference any of those values is the name of the dictionary and then the key inside square brackets, okay? So if we wanted to get the value, and it's really not a method, it's just a structure, just a statement. So country is going to equal from the country's dictionary code MX, which is going to return Mexico. We see it right here. And if we happen to refer to one that is not in our dictionary, i.e., we'll get a key error. Okay, it'll just tell us that particular code or that, and they go back and forth in the book between code and key, which is a little confusing. But anyway, if that key does not exist, then you'll get a key error. So in the next example, we're going to set the value of a key. So this does one of two things. It's going to either change the value if the key exists, or it's going to add a new key and set the value for that new key. So we kind of get a 2 for the price of 1 here. And it makes it easy to update the data that's inside our dictionary. So in the syntax is exactly the same. You can see a code that sets the value, which basically means changing the value of a key in the dictionary. So for key GB, we want to set it to United Kingdom instead of Great Britain. So we just enter the name of the dictionary, the key inside square brackets, and then equal sign and whatever you want it to be. That will set it. Okay, if we were to add one, it's exactly the same syntax. So if FR is not one of the keys in the dictionary, then it will create that key and add France. To me, that is like worth the price of using dictionaries. Makes it just so easy. It just minimizes the challenge of this. Now, the second way that we can access, and this is very important for our validation, for lack of a better term, our check to see if keys exist, is the in keyword. Okay, just like we have used in other situations, we can actually open the dictionary, look inside, see if a key exists with one simple little if statement using the in keyword. Man, that is so easy. So then if the keyword exists, then we can update it or whatever. And if we're trying to get the value and the key does not exist, we don't get an error, we can print out a statement that says that key doesn't exist for our particular user, so our user of the program. So key in dictionary is the syntax. So this is where the book starts using the word code instead of key, okay? And just realize if you read this too fast, it can be confusing, that they're really the same thing. So IE is the key that we want to look up, and we're just going to call it a code. We're going to create an object named code here. So put it in an if statement with the in keyword. So if code in countries, the name of our dictionary here, and a colon at the end, then country is going to equal from the country's dictionary, whatever that key is, that code, and it'll print it. Otherwise, it's going to print a message that that particular code key does not exist. So that's pretty easy, and I think it will be a strategy, but it's not the only strategy. Okay, there's a third way to access values in the inside the dictionary, and this one is kind of neat because it will not throw a key error. Okay, there's a method that is provided for us, and this is the get method. Okay, the get method of a dictionary. And the argument in the get method is going to be the key that you want to get the value for. Okay. The big advantage here is if there is not a key, then the get method does not say key error, does not throw a key error, but what it does is it'll return none with a capital N to make it nice and neat. So capital N-O-N-E. If that wasn't enough, it gives you a bonus, okay? If you do not want the default word none, you can change it with the second argument in the get method, whatever you want the default to be or the output to be if there is not a key. So this is very helpful. So two arguments. The first argument for the get method is the key that you want to get out of the dictionary. And by default, the get method is going to return the value for that key. So if the specified key exists, the method returns its value. Pretty simple. We'll see a lot of examples of that in the code. Otherwise, this method is going to return none, or if you enter the second option or parameter in the key method, it will return whatever you put there. So here's the example from the book. And because this is a method of the dictionary, we have to include the dictionary object dot get method and then the key that we want to get. Okay. So we get MX. Once again, we get Mexico. If we try to get IE, we get a return of none. If we use the second parameter option, whatever, okay, it is going, in this case, to be unknown, and it'll return the word unknown. So I think that's a pretty nice way to handle this problem. Now, there are going to be times where you want to delete a key. In other words, you have a dictionary, you're working on some data, and you want to get rid of something. So there is a DEL keyword that will simply remove the key from the dictionary. It's very simple to use. DEL, the dictionary name, and then the key in square brackets, okay? Once again, if the key does not exist, we will get a key error, but as we have just learned, we can use the in keyword in an if statement to check and see if the key exists before we delete it. And that will make this much neater, okay? So as we saw in our get situation a minute ago, now in the del situation, we will set code to be IE, and then if code in countries, if it exists, then country is going to equal whatever the dictionary code returns. That's going to return the value. Then we can del dictionary countries code. That will delete the key. Then we can print country was deleted, okay? If the key wasn't there in the first place, then we can use an else clause here to print that on the screen for our users. Now, if that wasn't cool enough, we can revisit our old friend pop. It's a perfect example, perfect tool to use in this situation. Remember, pop is a method, it's not a keyword. And remember that pop does two things. It will return the value of the key, and then it will delete the key, okay? Just like we use pop in a list, we can use pop in a dictionary, okay? So it returns the value of the specified key, then it deletes the key value pair from the dictionary. If the key does not exist, okay, pop gives you a second argument, just like it did when we were dealing with lists, gives you a second argument so that you can have a return in the case that to be the return if there is no key, okay? So I would certainly want to use that optional second argument with the pop method. So the book gives us the definition, returns the value of the specified key and deletes the key value pair from the dictionary. The optional second argument is a value to return if the key does not exist, okay? So pop works just like it did when we learned it earlier in the course with lists. Now, here's an example of using it in the real world here. So we will code IE again, same thing, code's going to equal IE. And then country, once again, because pop is a method of the dictionary, we have to include the dictionary's name. So countries dot pop, the name of the method, and then whatever the code is, which is IE in this case. And then the second argument is what we want returned if there is no key for code, okay? And then we can print country was deleted. And so if there's not a key, it would just say unknown country was deleted, I guess. I think maybe an if statement would be neater in that case. Still, it's just so easy, but you see how that works. Now, sometimes you'll want to delete all of the key value pairs in a dictionary. Just clean it all out, make it an empty dictionary. And so you do that with clear, the clear method of the dictionary. So you have to include the name of the dictionary and then a period and clear. And in this case, there's nothing that's going to be between the parentheses, just clear, and it'll clear out all of the key value pairs in that dictionary. All right, before we go to the next slide, I just want to peek at it there. Before we go to the next slide, are there any questions? Threw a bunch at you. Hopefully you hadn't gone back to sleep. Okay, so far we've learned several ways to look up the value for a key in our dictionary, how to add a key and a value. We've learned how to change a value. We've learned two different ways to delete a value, a key and a value, and then also how to delete all of the keys and values in the dictionary. So very flexible tools. So now let's talk about looping through a dictionary and creating that view object I tried to kind of preface at the beginning. A view object is going to be the contents of the dictionary based on your loop that you're going to run, a for loop to go through and get data. And we have those three different methods that I talked about that we can use to create the view object. Just realize the view object's not just a fancy word, okay? It is important to remember that a view object is linked to the dictionary. I don't know if the book makes that point strong enough, but it is very important to understand there's linkage between the view object and the dictionary. So if you create a view object, you're using it in your code somewhere, and then you go in and you change the value of a key, it will automatically be reflected in the view object. You don't have to recode that. That's a very strong point as you start working on complex programs. Also, since a view object is an iterator, it's easy to use it in a loop to uncover all the data that's inside your dictionary, okay? We can loop through using the view object. So those are the important things to consider about a view object. It's not just a fancy word. There are three different methods that allow us to pull data out of our dictionary, not just one value, but a bunch of values, okay? So the keys method will return a view object that contains all of the keys in the dictionary. This is the default behavior. This is the default iterator for a dictionary, okay? We can also use the items method, which is different. Now, the items method will return a view object that contains a tuple for each key value pair in the dictionary. Now, remember, tuples are a bit restrictive. You can't change tuples. So that if you just want to display what's in the dictionary, a tuple may be a good way to do this. And I don't want to get ahead of the chapter here, but there's another way to deal with a situation where you could change the dictionary into a list, which might be more productive. So anyway, this is a simple way to create a tuple. Just remember what a tuple is. And then values is a way to create a view object that contains the values in the dictionary. So three different ways that we can disclose what's in the dictionary. And we do it with a for loop, and we do it with a method. So very simply, and this is kind of the default behavior, we create a for statement. We have a code. This is going to be the key, okay? And we use the in keyword. Because keys is a method of the dictionary, we have to use the dictionary's name dot keys, then the two parentheses, and a colon at the end to terminate the for statement. And then we can print, and we would get a list here of the codes, some white space. We created an empty string here with a bunch of white space, and then the country's code. Now, notice that this is a get because there's the name of the dictionary and the key. So the automatic return here is going to be the value. So that would be the value of each of those codes. The output would look like this in our little simple dictionary we're using for our example. Now, because of this line right here, this is the default iterator for a dictionary. We could do it without the method, okay? So we could create a for loop, for code in countries, okay, the dictionary, terminate it with a colon, then print code plus the white space plus the value for each of those keys. It come out exactly the same way because the fact is that keys are the iterator. That means that would be keys. That would be keys, okay? And the keys method makes that keys as well. So I don't know exactly, and I can't explain why things are the way they are very well, but it gives you two ways to do the same thing there. I don't know. I like code that is easy to read and understand what the writer was trying to do. So I would lean maybe more towards using the method for that reason, just to make the code easier to read. Not all of your Python code readers are going to be as smart as you are and know that the key is the automatic iterator. So if they looked at the for loop, they wouldn't know that code is going to be the key in countries. And this is actually a for each loop, and go through all of the keys in the countries dictionary. All right. So next is the items method of those three methods we were looking at to pull out the data. And so this is going to create a tuple. It's going to return a view object that contains a tuple for each item and a for statement that will unpack the tuple so we can basically it's a two-step process. We're going to use the methods, the items method to create a tuple for each of the key value pairs. Maybe I didn't make that clear a minute ago. As a matter of fact, I want to go back and look. Actually, maybe I didn't even read this. I meant to, but the items method returns a view object that contains a tuple for each key value pair in the dictionary. And that's important for each key value pair, okay? But just remember, tuples are basically static. So we would want to unpack them. We would want to go through the tuples and change them into variables so we could do something with them. So we'll see an example of what we're talking about here. And it's really very simple. So, and I think the interesting part of this code is that we have both the key and the value unpacked here in the for loop. So we start a for loop, code equals the key, name equals the value in this case, in countries using the items method, okay? Now, since each time through, we're going to get a different value, a different key and a different value, we can print them each time through and get our list, okay? So that changes these two variables right there. So we can do stuff with them, okay? And then the third of those examples is the values method. And this is a lot like the keys method. It just changes the iterator to the value, okay? And so in the example, they went ahead and did that for us and just changed the name of the iterator here to make sense of this. So for each name in the country's dictionary, print it, okay? So just notice that we have to use the values method to get that to work. So I'm gonna pause just a second to make sure I didn't mess up the for loops for you. Do you understand what I was talking about with those 3 different for loops? Anybody have a problem? Doesn't hurt to ask a question. All right, let's move on. So just remember that dictionaries are unordered. So sometimes we will want to convert a dictionary to a list so that we can sort the list and put it into alphabetic order, whatever. That actually happens quite a bit in the examples that we're going to see later in the chapter. So we have to use a constructor method to create that list. And then once we have all the data that's in the dictionary converted to a 2-dimensional list, then we can start sorting things. Okay. So that is the next point in the chapter. So if you need to convert a view object, okay, first off, you have to have a view object before you can convert it. So you have to run one of those 3 methods to create a view object. And then you can convert that to a list. You can use the list constructor method, and that will do it, okay? And then once you have that list, you can use the sort method of the list, which we studied way back, I guess in Unit 6. I can't remember which unit it was. But once we have a list, which we can change, then we can run the sort method on it and change the order. And then if we have to, we can convert the list back to a dictionary, and then it would be sorted for the time being. But remember, there's no guarantee it's going to stay ordered. So let's see how we use a for statement to pull this off. First off, I'll look at the 2 constructors. List of a view object, and I don't know if I made that clear earlier, but the list method has to work on a view object. Converts a specified view object to a list. That means that we have to run either the keys, the values, or what was the third one? Items. Those 3 methods, one of those methods to create a view object, okay? And that will create a list. Now, the DICT dict constructor will work on a list and convert it back to a dictionary. The thing about this is that list has to be a perfect 2-dimensional list or a tuple, or it's not going to work. So it has to be a 1-for-1. You know, there has to be a complete list in both columns. So here is our dictionary that we're creating. We can tell it's a dictionary because it's enclosed in braces. And then we do a twofer here. We're going to create codes again, and it's going to be a list, okay? Because inside the list method here, we are actually the list constructor method. We are going to run the countries dictionary through the keys method to get a list based on the keys. So this is going to give you good data, okay? It's going to give you a list of keys, and it's going to be called codes. Now we have all those codes, we can sort them because this is the sort method of a list, okay? Now that we have codes, which is this sorted list, we can use a for loop with the end keyword to go through it. So this is a for each loop, and run it through a print. So for each code, for each value, we can add the white space that we saw before just to make this neat, and then do a get. We can look at the countries dictionary, it's still there, and based on the code that we pulled out, we can get the value and create our 2 columns here in the console. A lot going on in a small amount of code there. Anybody have any questions about this? This line right here is loaded with good stuff. So we have a method running inside another method, and the outside method here is a constructor. Okay. So remember that the list is not linked to any of the things in the dictionary. It is a one-time deal. So it is not a view object. We made the list from a view object. So once that list is created with the constructor, there's no relationship. It's just a list, which is fine for doing something temporary, but it's not fine for something for a long period of time in your program. I know this early in your education, becoming a developer, this might not make much sense, but what we're trying to say here is, and the book uses, if the long list stays in scope for a long time, that's kind of silly, but if you're dealing with a lot of data, let's assume your list has 1,000 items in it, and you're going to be tempted not to do anything with that data unless it's necessary or whatever. As long as it is a list, it is not linked to your dictionary. One of the things that's important about that view object is that it is linked. So you may want to turn that list, or you will want to, I'm going to be more assertive. So we will turn that list back into another dictionary, or not make any changes in that list. We'll be sure to make any changes to the data in the dictionary so that it is directly linked to the view object. That makes more sense when you start writing programs, I realize, but I'm just telling you to remember the list is not linked to the view object. It's a one-time deal when you create the list. Now, if you want to create a dictionary from a list, it is not hard to do. It can be a tuple, it can be a list, but it has to be two-dimensional, perfect, and all the keys have to have values. If there's a key without, excuse me. Early morning, my voice starts tickling a little bit. Anyway, if there's a missing value or a missing key somewhere, if it's not an exactly matched up two-dimensional list or tuple, it's going to throw a value error. So be careful about that. But you can convert it back to a dictionary if you want to, or create the list and then create the dictionary from it. So there's different ways to use that tool. So very simple code on that is super easy. So we're creating a two-dimensional list here. You remember this from earlier. So you can tell by the square brackets here that these are lists, and it is a two-dimensional list or two-dimensional array, if you want to use that word. And we can use the dict method to create countries dictionary, okay? And we know we created this dictionary if we print it, and you can see that it has braces on it and the colons and so forth. So it has the syntax that we have just learned for a dictionary. There'll be times when that comes up. So let's go to some code and see how we can use this. First off, we're going to continue on the same idea of a country code program, but create it in or move it to a kind of a helpful format. And as we have seen in other examples in this textbook, our console is going to start out with a command menu. And then we can just run those commands to get the output that we want. So view will give you all of the country codes that are in the dictionary. So this is an interesting piece of code to get this line. So it starts off with country codes, colon, space, that's a string. And then it gives a just a long, it finishes out the line with all the country codes. From those country codes, you're supposed to select one to view. So we enter MX here and we get Mexico. Okay, so that's kind of a two-step to function we have to create there. To add, we just enter a code. And so we want to make sure our code looks up to see if NL exists already. If it does, we need to deal with that issue. If NL does not exist in our dictionary, then it adds it to it. and then we can view again, and there's NL that we added, and we can look for it. We can delete the del, which is a different function. We just need to know the country code. And it's interesting, we don't get a list of country codes there. It'd be kind of interesting to do that. But we enter the country code that we want to delete, and it was deleted. Notice we are dealing with case here too. We have a bunch of lowercase entries, and we've got to change them to uppercase to get this to work. So the code is going to be fairly straight and to the point, I think. So we start off with the command menu. So it's a bunch of print functions. Then the display codes, and this is where that interesting line is created. So first off, we are going to use the keys method of the dictionary to create a list, a list here of all of the codes. So that's just a list of codes. Now that it is a list, we can sort it. So using the codes list with the sort method of that list, we can sort it into alphabetical order. And now we start building that line. So line is an object. We're going to start off with a string on that object, which is country codes :space. And then we're going to add a for loop where we'll go through that list of codes. And for each code in that list, we are going to add the code to the end of the line. Okay. So line plus the code and a space. And we'll add that little string space there between it. And that will, that's a really good example of how to use a for loop with the end keyword to generate some meaningful output. We can print each of those. Oh, it'll print one line because we keep rewriting that line every time we add a code to it. So at the end of the day, that line is just going to have all the codes off to the right there. Then our next function is going to be the view function. And so we want to run the display codes function that we just saw. And then we will ask for a code. The user will look to that list and come up with a code. We'll convert the code to uppercase. And then we'll go into another if statement to see if that code exists in our dictionary. So if the code is in countries, then name is going to equal the output of this get here. So the dictionaries look up the code. It's going to give us the value for that key, print the country name, a space, and then add the name and period and end of line character. Else clause, print there is no country with that code. Then to add, this one is kind of the same thing done a little bit differently as view. So we'll ask for the code, okay, and then we'll change the code to uppercase. We'll check to see if that code is in the country's dictionary, just like we did above, it's exactly the same code. Our else clause is different, okay, so here we will ask for a name, a value that we want to associate with that code, which is a key in our dictionary. So name is going to be the string that we want to add to that key. And so we want to convert that name into a title. In other words, capitalize the first letter and then all the other characters be lowercase. Remember that format method we learned? So we're changing the name object to the title format here. And then this is how we add, okay? So we're going to add for the code that we are entered up here, okay? We're going to add the name and then we'll print it that we have added that name to the, or value to the key. Then deleting is pretty simple. We want to check here to see if the code exists for the country you want to delete. So name is going to equal the code that we delete here with a pop. This is a good example of how to use that pop method. The dictionary is countries. We're going to run the pop method on that dictionary for a code that is entered by our user. and that's going to return this value for that key that is the code. And then we can use that name in some output here, name plus was deleted, or we can print that that code doesn't exist if we get a fail on this if statement. Then our main function is super easy. All we have to do here is create our dictionary, which is countries. It's a static dictionary to start with 3 countries in it. North America, I just realized that. And then we'll display the menu, start our while loop for our user to enter their commands. And based on these commands, we will run the necessary functions and exit out if we need to. And we have our if statement here to make sure this is the main module. So that is the country codes program. Any questions about that one? Good deal. Moving along, let's look at another program. So this is a variation on the word counter program we had earlier in the course with the Gettysburg Address text. But this time we're just going to count or show the words and the number of times that the words are in there. We're not really given the total number of words and all that stuff. Actually, at the end of the program, it gives you, the end of the list, it gives you a total number. And that's not even in our snapshot here. So a variation on that program. And because you've done the word counter program, this code that we're going to look at, it should be easier. Okay, so first off, we'll define get words from file function, and the argument is going to be locked in on the file name. And so we'll open up the file name variable as file, create a file object, and then we can use the read method on that file object to create text. Okay, so that basically changes the file to a string. Now that we have a string named text, we can use the replace method on that to remove all the end of line characters, the commas, the periods, and the commas. We did all that. Okay, so remove all this punctuation and change it to lowercase. And then we're going to split on the spaces in that text. So basically, after we converted the file to a string and removed the punctuation, the only thing between the words were spaces. So we're going to convert based on those spaces. We're going to create a list named words. This is exactly what we did in the word counter before. Then we can print words, which will give us the list and return words. Okay. Now we can count the words. It gets a little bit more interesting here. Count words, and we're going to work off of that words list. Okay. And we'll start off by creating an empty dictionary here. Word count is going to be a dictionary in this version of the program. So for each word in the words list that we created, if the word is in word count, then word count for that word is going to increment 1 time. In other words, we're going to add, increment or add 1 more count. Else, that would mean the word is not in the word count. So else we want to add it. So once again, just like we said earlier, if we do a get to see if a key exists in a dictionary, then it will add it. Now, I'm assuming that, maybe I shouldn't assume. Hopefully you figured out that this dictionary we're creating, the keys are the words. All the word strings are keys, and the value is the count, is the number of times that the word is in the Gettysburg Address. Okay, so else we want to create the keyword and we want the value to equal 1. I think this is all very interesting because it shows us a strategy on how to use a dictionary. And notice this is not a lot of code to get a lot of work done. That's why people like Python. So we want to display the word count. based on the word count dictionary that we created. Okay. So first off, we want to convert word counts to a list of keys. Remember, the words are the keys. So the word count dictionary is going to be run through the keys method to create a list. Is just going to be the words with no values. Okay. And then we want to sort them. And while we sort them, we also want to make sure they're all in lowercase. So key equals is a named argument for the sort method, and we want to use the string lower method in that case to make sure it's lowercase. That's kind of some interesting code right there too. So for word in the words list, we want a count to equal word count for that word. So that's going to bring the value. Remember, word is the key. So the value is the count. That'll be the count. And then we can print the word equals that number, which is the value. So this will be the key, an equal sign, and the value. Interesting use of a dictionary there. I like that. And then the main function is going to be pretty straight up, the name of the program, the file that we want to work on. So file name equals Gettysburg address. And then we just run our functions here. Words are going to equal get words from the file. Word count is going to be word count words function. And then display words is going to show us our counts. And then our if statement to say that this is the main function. Any questions about this piece of work, this program? I hope you study these examples. They are really, really helpful. All right, so let's move into the complex part of the program today, okay? How do we make this harder, okay? Up to this point, all we've been doing in our dictionaries are strings, a few integers, hardly any, and no floats, but we could have been using floats. So those are our basic data types. We haven't done anything very creative. So how about adding to our dictionaries lists, tuples, or dictionaries? So a dictionary of dictionaries, dictionary of lists, dictionary of tuples, or vice versa. It's very flexible. We can go crazy with this stuff. And we have some examples to show you this. And this first example is that address book we were talking about. They don't call it that, but it's what it is. So a person's name is going to be the key for a dictionary that's going to have a key for their address, a key for their city, key for their state, key for their postal, key for their phone, and their name is going to be a contact. Okay, contact is actually the outside or containing dictionary. Okay, so to build the contacts, I should have put an S on that, contacts dictionary, we create a bunch of embedded dictionaries. So the keys in the contacts dictionary are Joel, Ann, and Ben in this example. So these are the contacts names. That's what I was trying to say a minute ago. For all the data for each of these names, we have a second or embedded dictionary. And you can see there's 3 keys for each one of these. Actually, there's more. See, they didn't do what I thought they were going to do. They should have made this a little bit easier to read by bringing city over here and postal code over here and made 2 columns, but they didn't do that. This is the opposite of that. This is a long line that has truncated. I digress. So key is going to be address, key is going to be city, key is going to be state, key is going to be postal code, key is going to be phone. Syntax wise, that works. Easy to read, not so much. I stumbled over it because it wasn't easy to read. I rest my case. Okay, so we have 3 of those. So now we can see how to pull that data out, okay? We need to be able to access data inside those dictionaries. And we also have to take into consideration that our users may want to access something that doesn't exist, which could create a key error. So we have to put in if statements to protect that from happening, or use the get method, or do something, okay? And we'll see how we're going to do that. So when you have complex data, you have more code. I'll just go ahead and say that. So the way this works is kind of like a list, a two-dimensional list, in that when you reference the dictionary, the first reference is going to be for the containing the outside dictionary. I'm acting like this is embedded if statements, you know. So it goes from the outside to the inside. So for the user or contact Ann, we want Ann's phone number, which is in her dictionary. Okay, maybe that's an easy way to say it. And there's her phone number. But if I happen to reference email, which is not one of the keys, then there's going to be a key error for Ann. Now, there's several ways we can deal with that. The easiest, possibly, maybe not, certainly done often, is an if statement. So our key is going to be email. Say hallelujah. They quit using the word code. So if the key is in contacts and, so contacts is the whole dictionary, the whole address book, and we're looking at and, okay, so that makes sense. So if email equals contacts and key, which is email, then print the email, okay? Else print, sorry, there's no email address for this contact. So that would open the door maybe for adding that key later or something, I don't know, but that's kind of an interesting way to code that. I think that the main thing that we've got to see is how we deal with the embedded dictionary. So we work from the contact, which is the main contacts dictionary, and we look inside the and dictionary for the key in this case, which is email up here. All right, now another way that we could do this is use the get method, okay? Now that's going to present a perplexing little dilemma that is easy to fix, okay? Because when we use a get method into another get method, in other words, a get method for the contacts dictionary, and then a get method, say, for Ann's dictionary, then we're going to have a problem, okay? Because if we are missing a key in Ann's dictionary, that's going to mess up the contacts get method, okay? So you'll see what I'm talking about here. The way we can work around this is in the first get method, in the second argument, put an empty dictionary in there, and that will solve the problem. Remember, the default is the word none. Well, if we feed none into the second get method, it's going to mess everything up. All right. So in a perfect world, we are not going to ask for keys that don't exist. So in this first one here, in the contacts dictionary, we use the get method for and, okay, and then send that right into a get method for phone in Ann's dictionary, and that will work. And if email does not exist, okay, and exists, but email does not, that would return none, okay? Now, in this next one, I want to see something here. Yeah, okay. This doesn't make any sense unless I tell you this. In our contacts dictionary, there's no Mike, okay? There is no user Mike. So keep that in the back of your mind as you look at this. So in this case, Mike does not exist. So the problem is this get method is going to generate none, which will be sent to this get method. And now we're going to get an attribute error. It's going to mess up. Okay, and that's what I was talking about. So if we want to protect the contacts, the outside dictionary, we'll want to put an empty dictionary here as the optional default return, which that would return none. Okay, if we sent this empty dictionary to get phone, that would always return none. Okay, does that make sense? And everybody's going, okay, if you say so. If you say so, if Mr. Murak says so, it must work. All right, so we're going to see some examples here of how to store a list inside a dictionary, which is very common. This happens quite a bit. And as a matter of fact, there's some advantages to doing this. So we're going to have a dictionary of students. And for each student, we're going to have a list inside of their grades. Okay. Very simple on that scenario. So we know we're doing this because we have braces on the outside of our dictionary. And so the keys in our dictionary, thank goodness they put them in columns. So we got Joel, Ann, and Mike. Okay. And there's our colons. Okay. And then you see the value in each of those keys is a list. So we can pull up that list, real simple. Students dictionary, Joel's the key, there's the list. Or we can go crazy here and pull up the students dictionary, Joel, and index 0 to get his first grade. So we can actually reference or look up the list inside Joel's value. Okay. That's powerful stuff right there. And you'll see that in a lot of code. So that definitely would be complex, and it would certainly be useful in a lot of cases. Okay. Now, our last program for the day. Okay. The book catalog program. The book catalog program is going to be in your first lab. So I hope my explanation of the code, at least my version of the explanation of the code, will be helpful for you. And I want you to read along with me, because when I get finished with this, I'm going to ask you if I made any mistakes. So I'm not perfect, and you may see something that I overlooked. So let's take a look at the program. It is simply a program to catalog books, authors, and the year of publication. There's 3 things for each book, okay? So we want to be able to show the book, basically dump all the data for a book, add a book, edit a book, delete a book, or exit the program. So you see our command menu. So instead of view, we're using the word show here, and show will show the title that we enter. This is what we enter here, and it tells us, well, Heart of Darkness is not in our catalog, so we can add it. Okay, and so we add the title, the author, and the year. We can edit it and make changes. So this is a useful little idea. Now, before we go too much further, realize that if you can do this for a book catalog, this is basically a Python management system for a non-persistent database. If you just made this persistent by saving it to a file on your hard drive, this is a powerful thing, okay? This is getting into some real programming. So let's take a look at the code. Now, I went through yesterday in this code and highlighted the parts that I thought you would find really interesting, because they deal with the topic of the week. So first off, show book is going to be our first function we're going to create, and we're going to do this on the book catalog dictionary. And so we need to collect the title, okay? And so we ask for input from our users. Enter the title of the book, colon space, and that's going to create a string. Now, that means that the title of the book is going to be the key, okay? So if title is in the book catalog, then we can get the title for the book by looking at the book catalog dictionary and get the title. Okay, the title is going to be the book, okay? And then we can print the title, and we can print the author, and we can print the publication year. So those are just the same thing that we have looked at earlier in this unit. So each book is going to be its own dictionary. Does that make sense? That's why we wanted to get the book here from the book catalog. And then we still have title. We got title right here. So title can be printed, okay? And then we go into the book dictionary that we have here, the book object, and we can pull out the author and the pub year because those are keys in that dictionary. Or else we can just print a statement that says that title doesn't exist in the catalog. So that is the show book. Now we can look at edit and add. Actually, it works for both. Remember, it works for both because we're able to set or add with the same syntax. So add or edit book in the book catalog. And this is interesting. Our custom function has two arguments. The second argument is going to be the mode. Are we adding or are we editing? Okay. So if the mode equals add and the title is in the book catalog, and that's the in keyword. So right here, we're actually looking for that key, okay? Then we can add it. Or actually we can print a response that we can edit it. This would actually throw it into edit. So if mode equals add, I have to think about the logic here because we're trying to add a book, but first we want to see if it's in the catalog. And if it is in the catalog, we're going to be nice and give them a chance to edit it. Okay, so that's what's going on here. So we print the title that we collected up here, plus already exists in the catalog. Okay, so if this equal is true, it'll print this. And then we'll ask them, very nice, with this input function, would you like to edit it, yes or no? And we want to make sure it's a lowercase letter. And if the response is yes, then we will return that, okay? Else if the mode equals edit and the title is not in the, and notice the not version of the keyword here, if the title is not in book catalog, love this in keyword. It just makes it so easy to manipulate this data. Then we can print the title does not exist in the catalog. Would you like to add it? Okay, same thing, make it lowercase. And then if response is not Y, return. So we have two different scenarios here and we give them a chance to move on, okay? So if they add or if they edit, we'll get the book data and create the dictionary for that data. So we'll get the author's name from the user, we'll get the pub year from the user, and then we can create, very simply, this is an add, the author is going to be author and the pub year is going to be pub year for the book that we are working on. And then we can add the book if we need to add it simply by entering a book catalog, the title, which we collected way up here, and it is going to equal the book, which is right here. That's an interesting function. This function is different than anything that we've seen in the course so far. Okay. So we go to delete the book. Once again, we collect the title If the title is in the catalog, we'll delete it, okay? That is anticlimactic. But because we have the title here, we don't necessarily have to pop. So this will delete it, and then we can print title has been removed from the catalog. Else, the title does not exist in the catalog. So that's super easy. Then we have a display function that displays the name of the program and the command menu. Then we get into the main function. First thing we have to do is create our initial dictionary, which is our book catalog. Okay. We want to display the menu that we created. Okay. Do that. Then we have our while loop to go through the program. So while it's true, we ask our users to input a command to show, add, edit, delete, or exit. And then if they give us something else, we give them a unknown command error, and then our if statement to make sure this is the main module. So I ask once again, are there any questions about this program? Because you're going to have to do a lab on this. You're going to enhance it and make it even more complex. Any thoughts? I'll just kind of page through the slides here. Logan's good. I think Joshua put that yes in there a while ago, so I'm not going to worry about that. Any thoughts? Nathan's okay. Yeah, it's a lot. This is a whole different. The thing that I like about this unit is it's not only showing us new tools, but it's showing some strategy, some technique. And the more units we do, the better programmers we're going to be. And so I'm excited about it. I'm going to see how you guys do. Now, remember that Unit 12 is on the test that you're going to be taking on Monday, Tuesday, or Wednesday of next week. I changed the terms list from what's in the book. I added to the list map and symbol table. Remember that from the very first or second slide, I guess it was, in the stack here for this week, because I want you to remember the different names for a dictionary. You're going to run into this in your future career in technology, and I want you to not be surprised by certain terms. So just realize that associative array, dictionary, map, and symbol table are essentially all the same thing. Okay. So be sure and study the summary at the end of the chapter. It's a good little wrap up. Keep trying to sell that to you guys. I think it's something that you can read over and over, maybe print it out on paper and carry it around with you, or put it in your phone, study it. You can have the whole stack of slides in your phone. That's a good thing too. There's only 60 in this particular stack. So for this week, work hard on chapter 12. Download these slides. I worked on them yesterday. I don't think I saw any errors. Maybe I could have highlighted some different things in the code differently, but if I do that, I won't change anything else, but I don't think I will do that. Complete the topic for this week. I don't even remember what the topic is. I need to look it up. There are 2 labs. You're going to add a list method in the book catalog. So you're going to go in and use the list constructor method and change the way that we handle the data in the book catalog. And then in the second lab, you're going to tackle the movie list 2D, basically back to when we first saw that program, and you're going to use a dictionary to keep up with the movies in that program, which shouldn't be too complicated for you. I think that one will be okay. And then you have a quiz for attendance, and that is it for this week. That plus a test, no small thing. Okay. Any other questions I can help you with? We're actually getting done early. Yesterday, I got done way early. I changed a few things to give us a little more content this week or today. Well, I appreciate you guys hanging in here with me. I know that sometimes reading code is less than exciting. I forgot to ask you when I had slides up, I can put them back up if needed. Did you see any errors I made in reading the book catalog program? Did I screw anything up?
Didn't notice anything.
Okay, you have the opportunity to ask me why I said something, and probably I will say, oops, I messed up. All right. Well, you know, I just want you to know we're all human. We're all learning. You guys have a good week. You got a lot to do. And I know you probably have another class or two to deal with as well. Coming back after spring break is kind of a rude awakening for all of us. But realize we only have 3 weeks here to get the job finished. So we got a lot to do, and we don't want to drop anything between the cracks. So we'll see you guys next Wednesday morning. And if you have any questions in the meantime, send me an email. Thank you so much, guys. We'll see you next week.
Thanks a lot. Have a good week.